Hey everybody, welcome to Part D. Your secret word is Vicuña, because Part D goes over something you learned in 6th grade with Ms. Vicuña or Ms. Burke. You know what? Oh man, I'm adding Burke. You should just write down whichever teacher you had. If you write down both, I know you don't listen to a single word I say. You just put me on mute. Mute! Not even mute! I can't say words. Ugh, calming down. Okay. So one thing that you learned about in 6th grade was kind of a shortcut to help you divide fractions. And that shortcut, even though I don't like teaching shortcuts, it's just helpful for helping you solve problems in 7th grade. So, when you have 3/4 times 2, or 3/4 divided by 2/3, one easy way to solve the problem is just to change it into a multiplication problem. You do that by using K, C, F. So we take 3/4 and we do nothing to it. We keep it the same. We change division to multiplication, and we flip 2/3 into its inverse, which is 3/2. And then, multiplying fractions is super simple. All you need to do is multiply across the numerators and the denominators. 3 times 3 is 9. 4 times 2 is 8. The answer to this is 9/8. The problem with shortcuts is you really have to know when it's appropriate to use them. So if you look at C, it says 3/5 times 2/3. Since we're already multiplying, we don't have to change it to division. We can just use the multiplication algorithm, which just says to multiply fractions, you can multiply across. So 3/5 times 2/3. Well, 3 times 2 gives us a numerator of 6. 5 times 3 gives us a denominator of 15. For B, since we're dividing, we could change this problem into a multiplication problem using KCF again. So I have 5/6. I change division into multiplication, and instead of 1/3, I do the inverse, and I flip it to 3 wholes. 5 times 3 is 15. 6 times 1 is 6. You could leave this problem in this form, or you could simplify it. 15/6, if you divide by 3 over 3, you would get 5/2. And we've done so much with mixed numbers in this past second unit, that's the same as 2.5. Alright, for D, this is a division of fraction problems. It's just kind of written differently. It basically is saying 2/3, and then this giant fraction bar is division. We're dividing by 5/8. And again, since it's division, we can use keep, change, flip to change it into multiplication. Keep 2/3, change division into multiplication, and flip 5/8 so that it's 8/5. Then from there, you can do 2 times 8 is 16, 3 times 5 is 15, and that's the same as 1 whole and 1/15. As you're probably noticing, I'm going over each of these problems. That's because we really haven't gone over some of these before in class, and this break is a nice opportunity for me to go over it, and for you to kind of make sure that you understand it before we get back. Alright, so continuing on, this is called the silver level because some of the problems are negative fractions. So the process is still the same. -1/2 divided by -3/4. I see that we're dividing fractions, so I'm going to use KCF to change things into multiplication. -1/2, I keep that. Division, I change that into multiplication. And -3/4, I flip to its inverse of -4/3. Now, the only difference here is we're dealing with negatives, so the multiplication rules apply. When you're multiplying two numbers, even if they're fractions, if the sign is the same, the answer is positive. So since both of these are negative fractions, I know that the answer is going to be a positive fraction. So now I just multiply across. 1 times 4 is 4, 2 times 3 is 6, and it's positive because the signs are the same. The only other thing you could do here is divide it by 2 over 2 to simplify it. 4/6 in a simpler form, but equivalent still, is 2/3. Same idea with f. Again, this is just written a little funkily. We got 1/3, and then that huge fraction bar is division, so divide it by -4/5. Then, channeling your inner vicuña, we're going to keep, change, flip. This time, I know my answer is actually going to be negative because the signs are different. 1/3 is positive, -5/4 is negative. So I'm going to put the negative sign, and then I got 1 times 5 is 5, 3 times 4 is 12. So when you divide these two fractions, you get -5/12. I think you're probably ready to do this one on your own, so do that one on your own. Yeah, you better do that one on your own, otherwise we're going to fight. Just kidding, sort of. Okay, H says 15 divided by 1 and 1/4. If you want to use the same strategy of keep, change, flip, you can, but we have to do something first. We have to rewrite this mixed number as an improper fraction. 1 and 1/4, well, 1 whole is the same as 4/4, and then we have 1/4 as well. So that's the same as 5/4. So I'm going to write 15 divided by 5/4. Then 15 is the same as 15 wholes, or 15 over 1. And now I can just use keep, change, flip. 15 over 1. Change this to multiplication and take the inverse of 5/4, or flip it, to get 4/5. Multiplying across, 15 times 4 is 60, 1 times 5 is 5, and then 60/5 you can actually just use long division, or you could think 5 times what equals 60, and you should end up getting 12 wholes. Okay, state test level. Honestly, you should try this one on your own, but I'm going to go over it just so you can feel super good if you got it right, and if not, you'll feel super good because you'll understand what you did wrong, and we got to learn from stuff like that, and I'm talking too much. Alright, so this is a division of fraction problem, but first, notice that we have parentheses. Following the order of operations, you always start with the parentheses. So that means before we do anything else, we got to do this. Okay, so let's start with that. 2/3 minus 5/6. Well, 2/3 is the same as 4/6 if you multiply by 2 over 2. That finds an equivalent fraction. So now I'm going to change this problem so that it doesn't say 2/3 minus 5/6, it says 4/6 minus 5/6. And because we spent 32 days on integers, and I basically think using open number lines all day long, I'm like, oh yeah, I could do this on a number line. So I got 4/6, and then we're going down 5/6. I'm going to use go to a friendly number as a strategy to get me down to 0. And then I'm going to go down 1 more sixth, because that's all that's left over, and I got -1/6. And I think, yay, let me find my answer, and then I realize I'm not done with the problem yet, I've only done part of it. So, okay, -1/6, I'm going to remember that. -1/6, -1/6, I'm thinking of you, I'm not going to forget you. Okay, bring this guy over here. Now, the numerator is -1/6. The denominator is 3 fourths. Looks kind of crazy, but this is just a division of fractions problem, so I'm going to rewrite it again with my finger, because I didn't bring a stylus. Divided by 3/4. Channel my inner vicuña. I'm going to do -1/6 times the inverse of 3/4, which is 4/3. Let's see. I got 1 times 4 is 4. 6 times 3 is 18. Guaranteed about 30 of you forgot the negative sign, and that's okay, but understand why. The first fraction is negative, the second fraction is positive. Those are different signs, so this is going to be negative. Cool. I'm feeling good. I'm looking over here. I don't see my answer yet, but I know it can't be these, because those are positive. Then I'm like, wait, can I simplify this at all? And yes, you totally can. You could take -4/18 and divide it by 2/2, because 2 is a factor of 4, and 2 is a factor of 18, and I get -2/9, and now I got this. If you figured that out without me, cool. If you figured it out with me, cool. But feel good if it made sense to you, because that is the state test level. And that's it for part D. See you for the next one. Bye.